welcome friends. We were discussing fouling in heat exchangers. In our course heat exchanger fundamentals and design analysis, fouling in heat exchanger, and as it is there in all the title slides, most of the material I have taken from the very comprehensive book on heat exchanger by Shah and Sekulis. There are other information, but this book has collected information from many other source books. So, I have taken from this book, and but only a small portion what is there even in this book has been presented in this lecture. So, this reference I have given, it has got two purpose. First thing is that I like to acknowledge, and second thing I like to give this reference to persons who are interested in digging some more information regarding fouling. So, they can straightforward go to the book of Shah and Sekulis, get some more information. Further they can get the references given in that book. So, further information will be available in those references. Well, now so far we have seen different aspects of fouling, what fouling can do, how fouling can take place, what are the different types of fouling, little bit of mechanism of fouling. So, all these how fouling proceeds. Now, we know by this time we know that fouling is not good, and fouling is to be avoided, controlled, removed, whatever you may say. So, remedy for fouling: mitigation or control, removal or cleaning, and cleaning could be online, offline. Let me spend some time. Mitigation or control, that means we this is a very good strategy for many of the cases, that if we can prevent fouling, in many cases for health, if we can prevent, I mean if we become healthy and if we afford not falling sick, that is the best way. But when you cannot avoid sickness, you are not well in spite of your good care of health, then you have to take medicine. Then you have to take different kind of strategies, maybe sometimes one has to undergo an operation. So, it is like this. So, initially we have to do certain thing, so that fouling can be minimized or avoided. How it can be done? It can be done by selecting typical design of the heat exchanger. It can be done by of course, it is within the design, but it can be done by changing the material. So, material is also a part of the design, but when first I have talked about design, it is the configuration of the heat exchanger, shape, size, etc. And next is the heat exchanger material. It can be done by changing the operating condition of the heat exchanger. It can be done by some other thing. Let us say in some system I install certain filter. So, certain particulates, when there is a circulating fluid stream, certain particulates are getting caught in the filter. Or let us say that I have got some HVAC system, air conditioning system, I have to take outside air, and outside air there could be dust particle, dirt, etc. So, I have got a filter. So, obviously, I take care of certain amount of fouling at the upstream itself, and fouling will be less. On the heat exchanger surfaces, the deposition will be less. So, this is what we can do. So, these are strategies at the design stage, and then by doing all these things also we cannot totally avoid fouling. So, there should be removal or cleaning methods. How removal and cleaning could be done, that depends on many things, that how critical is the heat exchanger. So, then depending on that I have to take my cleaning strategy. Whether it is a whether it is a liquid liquid heat exchanger, gas to gas heat exchanger or gas to liquid heat exchanger. So, those kind of things. What kind of heat exchanger design it is? So, if it is a cell and tube heat exchanger, then obviously, we have got some sort of a cleaning strategy. Let us say that one strategy could be that we open the entire heat exchanger, take out the tube bundle, clean the cell side, clean the tube surfaces, etc., and put it back. That could be. For inside the tube, we can have some water jet or abrasive water jet or kind of a brass kind of a thing. So, those kind of things could be done. And obviously, the way I have explained, it is a time consuming thing. But let us say we have got a plate and frame heat exchanger or gasketed plate heat exchanger. There the opening is very easy. We have to open it, clean each of the plates, then put the gasket at the required space, tighten the frame, and again my heat exchanger is ready. In many dairy industries, food and beverage industries, the gasketed plate heat exchangers are used, and sometimes every day these heat exchangers are cleaned, because the product we have to get it is some sort of a edible product, and the cleanliness is very important. Not only that, the growth of foulant is very at a very high rate in this kind of heat exchanger, as we are dealing with some sort of a food material or biological fluids, etc. So, it depends on many things. Suppose there is a big heat exchanger, how should I clean it? That will depend on the size of the heat exchanger, but let us say I have got a micro heat exchanger. Simply it can be put in a furnace, and temperature can be controlled at high temperature of course, but the temperature can be controlled, which is called baking, and we can get rid of most of the foulants which are deposited on the surface. So, but a large heat exchanger in that way we cannot put it in a furnace. So, there are different strategies and different ways of cleaning the heat exchanger. Now, they are divided into two parts like online and offline. Online, offline, the demarcation is again little bit fuzzy. One may call online when you are not removing heat exchanger from the total circuit and keeping the heat exchanger in situ, you are doing the cleaning. But let us say for the time being, when you are cleaning the heat exchanger, your heat exchanger is not a part of the active part of the plant. So, some sort of bypass mechanism is there and you are cleaning the heat exchanger. So, some people call this also as online cleaning of heat exchanger, and some people are very stringent in defining it, that online cleaning means it will not affect the performance of the plant, the plant will run as it is, and the heat exchanger is to be cleaned. So, very few heat exchanger will give you that opportunity, and offline in most of the cases you have to take the heat exchanger out of its place. Maybe in the same plant you can clean it, maybe you have to take it somewhere to clean it, and there are elaborate procedure for cleaning the heat exchanger. Now, cleaning there could be different strategies. I think I will not have opportunity to discuss all such strategies, but there are different strategies of cleaning, that by brass, as I have told, by chemical cleaning is there, mechanical cleaning is there. So, different strategies of cleaning is there. Let us go to the next slide. Prevention and control of liquid side fouling. Some of the methods for mitigation of liquid side fouling are as follows: chemical additives, dispersants or coagulators for particulate fouling, dispersants, crystal modifiers and chelating agents for crystallization fouling, inhibitor or surface filming for corrosion fouling, biocides, dispersants, biostats for biofouling. So, different type of fouling and what can be used. Now, you see sometimes the situation is very tricky. I have already mentioned in one of the earlier lecture that cooling towers are very prone to biological fouling. And cooling tower, what does it do in a power plant or let us say in a big refrigeration plant? What is the purpose of a cooling tower? So, in the condenser, the refrigerant is to be cooled, and the refrigerant, when it is getting cooled, let us say it is a big water cooled refrigeration system. So, the water is getting heated and that hot water will be taken in the cooling tower to cool it, coming in contact or bringing it in contact with the atmospheric air. So, the water circuit, there are two heat exchangers. One is a condenser and another is a cooling tower. So, in the cooling tower there will be biological fouling, and in the condenser there will be different kind of other conventional fouling like deposition, etc. And there could be some chemical corrosion also. Now, to prevent the biological fouling, what one can give, some sort of a chlorine dosing, etc. one can give, some sort of a chemical what one can give, that will prevent the biological fouling in the cooling tower. But most of the cases that will have a detrimental effect on the tubes of the condenser. So, you see one has to strike a balance, and mitigation of fouling or control of fouling is not that easy job, because many cases there are different mechanisms of fouling. If you want to suppress one mechanism, the another mechanism gets assisted by your method. So, one has to be judicial, one has to take proper precaution, and in some cases some sort of optimization is to be done, some sort of optimum strategy is to be taken. Process adjustment, monitoring, modification and replacement of devices, water flow reduction and recirculation strategies are good. These are process adjustment. Physical devices for cleaning like single sponge ball cleaning, the use of reversing the flow, subtle brushes, etc. So, this is what I have told, that you have got brass, let us say nylon brass, and in the circulation system these brushes are also moving from one end to another end, and while they are moving they are not allowing any deposition on the surface. Okay. Then utilization of enhanced heat transfer surfaces and devices, it has sizable influence on fouling mitigation. The use of tube inserts in particular in refinery processes such as wire mesh, oscillating wire, rotating wire are standard method. So, using of these heat transfer augmentation devices, which will augment the rate of heat transfer, at the same time when they are moving components. So, they will give some sort of delay in fouling deposition. Next slide, if we see various alternative devices and methods like magnetic field, radio frequency, ultraviolet and acoustic radiation, electric pulsation, surface treatment, fluidized bed design, these are all different methods. The most frequently used technique for preventing water side fouling is still the conventional water treatment. So, we have water treatment, we give treated water, sometimes deionized water, sometimes water with some chemical additive to the circuit, so that we reduce the water side fouling. as water is in many cases one of the main constituent of the liquid stream. So, that is why the discussion is to some extent biased towards water. It does not mean that there cannot be other kind of liquids, there are other kind of liquids, but water is very common industrial fluid, and that is why it has been told. And water treatment is a very common practice in large industries, so that fouling can be kept to the minimum. Well, heat transfer mitigation techniques can be applied either on or offline. Online techniques usually used for tube side application include various mechanical techniques, flow driven or power driven rotating brushes, scrapers, drills, acoustic, mechanical vibration, air or steam lancing on the outside of the tube, chemical feeds, flow reversal, etc. So, these are the different methods by which we try to rejuvenate the heat transfer surfaces. We try to get the deposition dislodged, we try to clean the surfaces, so that the heat transfer again become good. In some application, flows are diverted in a bypass exchanger, then the fouled heat exchanger is cleaned offline. That is what I have told, that fouled heat exchanger is to be taken out and to be cleaned. Other offline techniques without opening the heat exchanger include chemical cleaning, mechanical cleaning by circulating particulate slurry, thermal baking to melt frost, ice deposits. So, this is also thermal breaking is also done. Sometimes what happens that frosting is very common in evaporator of an air conditioning system, and in that there should be heater inserts, and with this inserted heater time to time heating will be there, and that can melt the ice and give the good performance. Offline cleaning with a heat exchanger opened or removed from the site include high pressure steam or water spray for a cell and tube heat exchanger, and baking compact heat exchanger module in an oven to burn the deposits and then rinsing. If fouling is severe, a combination of methods are used. So, sometimes the depositions are so heavy that real mechanical impacts are to be given. Okay. Chemical cleaning is also not sufficient, real mechanical hammering kind of impact is to be given, and then of course, chemical cleaning. So, there are combination of methods to be used, and a golden rule is that the cleaning schedule should be such that deposit layer are not so heavy or so tight, so that the separation or removal of the deposit layers becomes a very formidable job. Prevention or reduction of gas side fouling. The standard technique for control and reduction of fouling on the gas side are techniques for removal of potential residues from the gas. So, that is what I have told, that just putting a filter will prevent many of the problems. If you put a filter, so that will provide that will give a good solution. That is one thing. Another, that additives for the gas side fluid, surface cleaning technique, obviously surface cleaning technique ultimately you have to have, then adjusting design upfront to minimize fouling. So, that is always a good practice. Control of gas or liquid side fouling should be attempted before any cleaning method is tried. The fouling control procedure should be preceded by verification of the existing fouling. So, what kind of fouling is taking place, that has to be assessed, and then only some sort of fouling control procedure is to be adopted. Identification of the features that dominates the foulant accumulation. So, first thing, what kind of foulants are generated, first point. Second point is that how these foulant points accumulate or gets deposited, then characterization of the deposit. So, you see whatever we have discussed, if really one has to take care of it, the chemistry department of the plant, that has to be very careful, and that has to do a good kind of analysis, that what is the chemical composition, physically what is happening. So, then only one can have a good strategy of fouling control, and same heat exchanger can be used for different applications. So, a gas to gas heat exchanger can be used for different purposes. In one case it is using the flue gas, in another case it is using some sort of a hot gas, or flue gas it is using from two different sources. Okay. So, the foulings will be different, and the cleaning strategy, that will also be mitigation or cleaning strategy, that will also be different. So, this part one has to be very careful. Some of the methods of mitigation of gas side fouling are as follows. Crystallization fouling can be prevented if the surface temperature is kept above the freezing of the vapor from the gaseous stream. The solidification can be minimized by keeping a high velocity of the freezable species having some impurities in the gas stream. So, if there are impurities in the gas stream, sometimes the freezing is getting freezing gets delayed. Particulate fouling can be minimized. In gas side, particulate fouling is also very common, and increasing the gas stream velocity if it flows parallel to the surface, and decreasing the velocity if it impinges on the surface. Okay. So, please see, increasing the gas stream velocity when it flows parallel to the surface. So, that this will prevent deposition, and generally impact that gives deposition. If you increase the velocity of an impacting gas stream, that will decrease the deposition, particle deposition. Increasing the gas exhaust temperature above the melting point of the particulates. So, sometimes what happens, that there are certain constituents of the gas, product of combustion, mostly product of combustion. Sometimes it could be reaction product, some other reaction product. So, when it passes through the heat exchanger, the temperature of the gas stream that reduces, and that can go below certain temperature, where some of the constituents are they liquefy, or even desublimation process could be there, and they get deposited on the heat exchanger surface. So, this can be prevented if the temperature is such that such kind of phase change are not possible, then we can avoid this situation. Minimizing the lead content in gasoline or unburnt hydrocarbon in diesel fuel. So, you can understand why this has been told. Reducing the fuel air ratio. Okay. Then by minimizing the flow impact, minimum flow cross section 3 to 4 times more than the maximum particle size. This is just a thumb rule. Chemical reaction fouling can be minimized by maintaining the right temperature in the exhaust gas with the within the heat exchanger, increasing or decreasing the velocity of the gaseous stream depending on the application. So, sometimes we have to, by increasing the velocity of gaseous stream, it is convenient, sometimes the reverse is good. Reducing the oxygen concentration in the gaseous stream. So, many times this oxygen, and particularly at high temperature, that gives some sort of reaction, and reaction may be in the gas stream, may be on the solid surface itself, and that gives deposition, fouling deposition, even corrosion, which we will discuss. So, that is what we have to do, replacing the coal with fuel oil and natural gas. So, coal combustion is gives more pollution or more pollution, that is one thing, but it gives more fouling. Tendency of fouling is much more in case of coal combustion, because there are particulates, there are unburnt carbon particle. The way the combustion of the fuel air is efficient, the same way the coal combustion may not be that efficient. And of course, natural gas combustion, that is also very efficient combustion, there is no particulate, etc. Decreasing the fuel air ratio once again. The corrosion fouling can be controlled by maintaining the exhaust gas temperature above the dew point. See, above the acid dew point, if we maintain the temperature, then there will not be any kind of formation of acidic deposits. And then material selection is very important. SS, that means stainless steel, glass, plastic and silicon are resistant to low temperature corrosion. So, if we have low temperature application, we have to select this kind of material. So, that is less than 260 degree Celsius. 260 degree to 815 degree Celsius, superalloy to superalloy and stainless steel can be used in this range, and superalloy and ceramic can be used for high temperature application where the temperature is higher than 815 degree Celsius. So, these are some sort of a strategy by which we can avoid corrosion. Now, avoid fouling. Now, with that we are going to corrosion, corrosion in heat exchanger. Corrosion refers to destruction of heat exchanger surface. Fouling is deposition on the heat exchanger surface, corrosion is destruction of the heat exchanger surface. Now, these two are very closely related. Sometimes fouling can give rise to corrosion and sometimes corrosion can give rise to fouling, because due to corrosion some materials from the heat exchanger surface is coming out that can get deposited and create fouling. So, sometimes both of them exist side by side. Depending on working fluid, surface temperature and working condition, the corrosion will occur. Like fouling, it is complex in nature and also in transient. So, here there is a very interesting figure. You can see that what are the different factors influencing corrosion. Environmental factors are there, material factors are there and stress factors are there. Stress is very important in case of fouling, in case of corrosion. And you see these three factors, this is the zone of corrosion. So, this is the zone where environment and material are interacting, there is no stress factor. This is the zone where three factors are responsible. So, environmental factors are there, material factors are there and stress factors are there. I am not explaining this figure each and every item. So, you can go through it and you can understand what has been told and what are the this is almost self explanatory, that material factors includes composition, alloying elements, heat treatment, effect of fabrication, microstructure, surface condition, passivity, tendency for fouling. So, all these things, and similarly there are design factors and there are environmental factors. Now, if we go to the next slide. So, types of corrosion. So, there could be uniform corrosion everywhere of the heat exchanger surface, same kind of material loss is there due to chemical or electrochemical reaction. There could be galvanic corrosion, like two different metals are there, they do have different potentials and in between there is an electrolyte. So, this forms some sort of a cell, electrolytic cell, and then there is corrosion. Then pitting corrosion, local autocatalytic corrosion and there will be material loss. So, you can see the surface has become very uneven. Uniform corrosion, theoretically at least, there will be uniform loss of material from everywhere. Pitting corrosion, there will be selected places where the corrosion has taken place. So, we can see pits or small holes or things like that. Then stress corrosion. Corrosion is very much related to stress. It involves cracks on susceptible metal due to presence of tensile stress and corrosive fluid. So, when there is a material is stretched, highly stretched, so corrosion takes place. Then erosion. Erosion, you can understand that some material is getting eroded. It could be physical action, it could be even chemical action. Crevice follows corrosion, localized physical deterioration caused by deposit of dirt and corrosion products, etc. Then selective bleaching and disalloying. There are alloys. So, alloys will have number of components and then only one component or some selective component is getting dissolved. Only one component is reacting chemically and getting removed from this space. So, then we will have material with different composition. Material with different composition means it may be that initially what composition was there and finally after the corrosion we will have different kind of composition, or place to place we can have different kind of composition and it will weaken the structure. So, obviously, this is not good. So, with this I come to an end that very quickly I have told you regarding fouling and then I have told certain thing regarding corrosion, which is also one kind of detrimental effect which we can see in heat exchanger. And we have to avoid this thing. Some of the strategies I have told, particularly regarding fouling, I have told some of the strategies. For corrosion also there are certain strategies what one can adopt. So, I have given the reference, please go through the reference, you will have some idea how corrosion can also be tackled. That book will have cross references. If somebody is more interested, then he can go through the cross references. Thank you for your attention.